So we are back, guys, and we are talking about another example for constructing a confidence interval. And this time we are studying some car accidents in Collin County. There's 80 of them in particular, and it showed that 46 were alcohol related. Wow, guys, please don't ever drink alcohol. It's so bad for you. Now, we want to construct a 90% confidence interval to estimate the true proportion of alcohol-related accidents in Collin County. And then we're going to do our thing where we write an appropriate sentence. So we should identify here what is the sample size. And of course it's 80. There's a survey of 80 of them, so that's our little n. And then it showed that there were 46 alcohol-related accidents. And since we're studying the proportion of alcohol-related accidents, that would be, this is kind of one of the ironic ones where it's weird to call it a success, but having an alcohol-related car accident is a success. So that will be X. And then we want to make this time a 90% confidence interval. So we actually will have to change that one in our calculator. But let's go ahead and make this confidence interval. See what we can tell about it. We will go to one prop z interval. That time I went by going down, but it's not any faster. One prop z interval, because it's a proportion, of course. We don't want to mess with those other ones. Here it goes. There's 46 of them. And might we check after we find the p hat? And let's just do that. I suddenly decided that we should find the p hat because we need to just, for administrative purposes, we should check this thing, right? If our sample is large enough. So p hat is going to be the one x over n, so 46 over 80. Which, what is 46 over 80? Oops, I don't want to be in there. 46 over 80 is 0.575. So then q hat is going to be 1 minus that, which appears to be, just by looking at it, probably 0.425. Correct me if I'm wrong. And now we want to multiply our sample size, which is 80, times the 0.575 times 0.45. And it's 20, so it's just more than 10 by double, which is great. That means our sample's large enough. So why don't we go back to what we were doing before, making the confidence interval. It's down here. It's letter A. It wraps around to become A is one prop z interval. We have 46 there. We have 80 total car accidents. The confidence level this time should go 0.90. And now let's find this one. Our interval is 0.484. I will just round it to 3 decimal places up until 0.66. It rounds to 0.666. I hope you're not superstitious. But anyways, we can make a sentence out of this one. It would be the familiar sentence where we would say we are 90% confident that the true proportion of car accidents that are alcohol related is between these two values, 0.484 and 0.666. Period. That would be the end of the sentence. It's very simple to do that one. But now we will come up with the margin of error from this one just by inspection. We will see what is the margin of error in this case. And then a little bit later, we will actually calculate what the margin of error needs to be for, a certain situation, or what is an acceptable sample size for a particular margin of error. We will do more calculations with margin of error that are a little bit more sophisticated than this one. But in particular, what can we tell? The confidence interval, and I would like to draw a very straight line, is going to be on this number line. The point estimate, in this case, it's our one over here that goes p hat, and we found it already anyways. It's the one that goes 0.575. And then our confidence interval, it goes from 0.484 up until 0.666. And so the margin of error is just the difference on either side, the difference between the point estimate and this bound, or else the difference between the point estimate and this bound. And so we can just subtract one of those. The margin of error, which I would just write it as capital E, the margin of error is just that difference, like 0.575. And you can check, it will be the same on both sides. It doesn't matter which ones you subtract. You could even subtract these two numbers and just divide it by 2, because the distance between these two, it will give you this whole distance here. And then you can just divide it by 2. It will give you the margin of error, which is just on one side. But I'm just choosing to subtract it this way. And so what actually is that going to be? 0.575 minus 0.484. The margin of error is 0.091. And then the point estimate was this one. This over here is our p hat. So it kind of shifted down a bit. You know, we answered that question above the question, but that's okay. And now we can move on. I think it's getting pretty simple to actually make the confidence intervals. But right now we want to talk about something that's called a critical value, because we're going to use this to determine what sample size is needed to obtain a certain desired margin of error, for example. And the critical value is going to be actually this thing here. And it's a little bit funny of a symbol, but we will build up to it. Why don't we first, we're just working through this example, we're hoping to find the critical value corresponding to a 90% confidence interval and we will talk about the alpha value. We saw the alpha value already. Whenever you have 90% confidence, the alpha value that corresponds to that one, of course, is 0.1, because 1 minus 0.1 is 0.9, and then you go times 100%, you will get this one. We saw how to find the alpha before. Alpha divided by 2 is obviously just 0.1 divided by 2. I know that you can do it in your head, is 0.05. And now we're hoping to find the one that's called Z alpha over 2. Now what this means, whenever you have something that goes like Z, it's kind of the same way that we saw before with, you know, the percentiles and so forth. You would have a P with a little subscript on there. The Z, and then if you have some number down here, I suppose I can put alpha or anything, but I will put Z little n. This is the Z value that has an area to the left of it of little n. So this area should be there. If this is Z little n, then this area here should have an area of little n. And so it's going to be a number between 0 and 1. Obviously, it's probably going to be pretty small. But anyways, we will just find Z alpha over 2, which with that context, what we're hoping to find is such a Z score, as it were, and it's going to be called Z alpha over 2. And what that means is that this area here on this little tail should be alpha over 2. And it kind of makes sense that it should be alpha over 2 here, because if we just have the mean here, and then on this side, it's just going to be also kind of Z alpha over 2 again, but the positive version. It will have an area of alpha over 2 over here, because this is going to be symmetrical. And so then these two areas together are the alpha value of 0.1. So these two areas will add up to 0.1. That leaves 0.9 to be in the middle. And we can find this Z value. You must ask yourself, and you can pause to think about this one, but how can you find the Z score or the Z value that has a particular area to the left of it? There's a calculator button for that. Do you remember? It must be, and I know that you thought of the right one, it should be the one inverse normal, right? Inverse normal, which was under, it should be under the distors, right? Second vars, number 3, inverse normal. And what we want is to find the z-score, which inverse normal will tell us, the z-score that has an area to the left of it of 0.05. And so we will find, we want the area over here to be 0.05. And you know, z-scores have a mean of 0 and a standard deviation of 1. It's also called the standard normal distribution, if you can remember that one. And we want the tail to be on the left side. And so the z-score that we want in particular, and really in this case, since it's symmetrical and we want this center value, then what we can put right here is, I think it's going to be okay to put just the positive one, 1.64, and then I will go 645, just by rounding it. So really it's kind of plus or minus. I actually will even put that one. But what you're going to see whenever we are using this in the formula is that we're going to square it anyways. So if you put negative or if you put positive, it doesn't matter. Once you square it, it's going to be positive no matter what. So why don't we find these critical values for different confidence levels? We already found alpha over 2 for this one is 0.05 for 90% confidence. And the critical value was 1.645. And each one of these will have a unique critical value, so you can kind of just find these in this, you know, you won't have to necessarily find it each time if you can remember these. But what about for 95% confidence? Alpha is, of course, 0.05 to correspond with this one. Alpha over 2, it would be 0.025. And so then if we want to find the z-score that goes with that one, we need to do inverse normal again. And it's in the distors inverse normal. This time we want the area to be 0.025. And so what is that z value? It's the one that goes 1.9. I suppose we can call it 1.96. And this is kind of familiar if you think about, you know, the empirical rule. What is the empirical rule? You must remember it. It says, right, that it was 95%, right? 95% of the data is supposed to be within 2 standard deviations of the mean. So this is almost 2. It's very, very close. And 95% is in between basically 2 standard deviations. What about this one? 98% confidence. We have the alpha is 0.02. So alpha divided by 2 should be 0.01. So then the z of alpha over 2, we will have to find it again. Inverse normal. This time we want the, and then we will get rid of that one. We want the area to be 0.01. The mean standard deviation, it all stays the same. We'll calculate that one. So this critical value should be 2.3, I would just call 33. By rounding. And then last but not least, we should find the alpha over 2 whenever alpha is 0.01. This corresponds to 99% confidence. If you divide that one by 2, shoot 0.005. So then we need to find inverse normal for this one. And we want the area to be 0.005. And then we want the tail to be on the left. What is it going to be? It's going to be a z-score 2.5. I will just write 5. You should be probably an 8 here. We will just round twice to 2 decimals. So here this could have been on 6.5, but it's not too big of a deal. We're going to use these kinds of values, and we will see about determining the correct sample size based on these confidence levels. And we will just pick it up back here.